Basic electric terms video blog 7. How does an AC generator, alternator, work? The source of AC power. Our next question is, how does an AC generator, alternator, work to create the electricity we use in our homes? An alternator converts mechanical energy from sources like steam, water, or wind turbines into electrical energy in the form of alternating current, AC. Reliance on Faraday's law. The operation relies entirely on Faraday's law of electromagnetic induction. This law states that if you move a conductor through a magnetic field, or move a magnetic field past a conductor, a voltage, and thus current, is induced in that conductor. The two key parts. An alternator consists of two main parts, the rotor, the spinning part, and the stator, the stationary part. The rotor, creating the field. In large utility alternators, the rotor is typically an electromagnet. DC current is fed to the rotor windings to create a powerful, spinning magnetic field, north and south poles. This is the source of the magnetic flux. The stator, inducing the current. The stator contains the main stationary coils of wire, called the armature windings. These windings are positioned to be cut by the magnetic flux lines as the rotor spins rapidly inside them, generating the voltage. As the spinning magnetic field sweeps across the stator windings, it induces a voltage in those wires. This is the moment mechanical energy, rotation, becomes electrical energy, voltage. Why the output is alternating? Because the rotor's magnetic poles are constantly rotating, the direction of the magnetic flux cutting the stator windings continuously reverses. This causes the induced voltage and current to periodically change direction, hence the term alternating current, AC. The sine wave output. This reversal in polarity creates the smooth, characteristic sine wave that represents AC power. The rotation speed determines the frequency, e.g., 50 or 60 cycles per second, or Hertz. Three-phase advantage. Large alternators often have three separate sets of windings in the stator, positioned 120 degrees apart. This produces three-phase power, which is more efficient for transmitting power and running large industrial motors. Practical use. When you turn on a light switch, the power you use originated from a massive alternator where steam, wind, or water forced a powerful electromagnet to spin, generating that clean sine wave into the grid. The high efficiency. Due to their robust design and simple principle, large alternators are incredibly reliable and are the undisputed workhorses of global power generation systems. Final energy point. The AC generator elegantly uses rotation and magnetism to transform raw mechanical power into the rhythmic flow of electricity, making modern civilization possible.